What you're about to watch is Claude, the AI, interacting with Drill2Frac's curated data through MCP. The pad is yours, 11 wells across 4 landing benches. 5 questions, 1 conversation, a completion design decision at the end. The kinds of questions that once took days of back and forth can now happen through an AI-enabled workflow.
All right, let's get started. Compare the wells for Magic Kingdom Energy on the Mickey pad. What are the main differences in rock properties and how might that impact completion design?
Claude does a job that would normally take half a day. It reads every bench's curve catalog, pulls rock property statistics, compares completion scenarios, and synthesizes the contrasts in seconds. You didn't ask for a report. You asked a question and got a focused answer built from curated near wellbore data, instead of manually sorting through spreadsheets, PDFs, and disconnected datasets.
Okay. Which of the wellbore properties on these wells are likely to have the largest impact on varying well productivity?
This is where retrieval becomes analysis. No new query. Claude is synthesizing across the first question's curve catalogs. The ranking is grounded in actual ranges seen on this pad, not generic textbook drivers. And it ends with Claude saying it can't see landing precision and offset effects, which is exactly the hedge an experienced analyst would write.
Pull the wellbore details for Mickey 10HBU and list the flow effect scenarios that have been run on it.
Now Claude narrows from the pad to a single well, the deepest one, in the most challenging bench. The metadata is right there, so is the scenario history. 2 completion designs already in Drill2Frac's curated dataset, ready for you to compare. Notice Claude reads the timestamps and tells you what kind of scenario perfect is. That's the difference between a tool that returns rows and an agent that reads the data.
Recommend which of the completion scenarios would be optimal, and give reasons why I should pick one over the other.
This is the value moment. Prior to AI, you would have asked us to compare these 2 designs, and we would have shipped you a PowerPoint 2 days later. Today, you ask the question, the data lands, and the answer is on the screen, with the why. Pick perfect. 25% more productive clusters, no extra pump rate, no extra horsepower, a 110 psi pressure premium that's not a real constraint. And here's the deeper read. The BU bench has the widest rock strength heterogeneity on the pad, and limited entry redesign is exactly what beats heterogeneity. That synthesis is what you'd otherwise pay a consultant for.
Okay. Create a graphic to demonstrate how near wellbore rock properties change in this field from west to east.
And here's the geologist's view. Same data, same Drill2Frac MCP, but now Claude picks 10 wells across 10 pads, controls for bench, sorts west to east, and tells you what's happening across the asset. 2 takeaways. The in-situ stress map and the rock strength map are telling different stories. Depth alone is not a good proxy for rock quality. That's a regional analysis that would normally be a week of subsurface teamwork. To learn more about Drill2Frac's curated dataset and MCP capabilities, contact your Drill2Frac team.